Hello, my name is Andres,
My name is Emmanuel.
My name is Wendy.
And my name is Laura.
and our teacher is Edgar Arturo Orozco, and this is rational functions.
A rational function is a function of the form f of x equal to p times x over q times x, where p and q are polynomials, and assuming both of them have no factor in common.
The domain of a rational function consists of all real numbers x except for those of which the denominator is equal to 0. We must check the behavior of the graph near those x values.
The line x equals to 0 is a vertical asymptote in the function y equals function f of x. Of the function y equals to f of x, if y approaches plus or minus infinity. Of the function y approaches f of x, if y approaches plus or minus infinity, as x approaches a from the right or left. The line y equals to b is a horizontal asymptote of the function y equals f of x, if y approaches plus or minus infinity.
If n is minor than m, then r has an horizontal asymptote y equal to 0. If n is equal to m, then r has an horizontal asymptote y equal to a over b. And if n is bigger than m, then r has no horizontal asymptote. In this case, if it's bigger by just one number, then it's a slant asymptote. In this case, we just need to divide and see the behavior.
In this problem, we're going to represent increasing of population of rabbits in a community, where P of t equals 2015 t divided by t plus 2, where t equals 1, and it is the time, and when t equals 1, is the year 2001. This is a rational function, and we're going to obtain the asymptotes and the graph of the function. First, to obtain the horizontal asymptote, we need to get the limits. Limit as x goes to infinity of the function p of t. As you know, to get the limits, we use the formula. The exponent is equal, so we divide the coefficients. So we get the limits. So we have horizontal asymptote at y equals 2,500. And in the vertical asymptote, as you know, is the restriction of the domain. So the possible vertical asymptote is at x equals minus 2. So to prove this, we get the limits. And we have to also evaluate the function with minus 2. As you see, is a number divided by 0, so it's a vertical asymptote. So here in the limits, we can infer from this that we have a vertical asymptote at x equals minus 2. Near the vertical asymptote, as x approaches minus 2 from the right, y approaches minus infinity. As x approaches minus 2 from the left, y goes to infinity. Also, we can get the x and y intercepts. Okay. You know that in y-intercepts, x equals to 0. So here is 2,500 by 0. So 0 plus 2 equals 0, 2. That's 0. So the y-intercept is at 0, 0. And in the x-intercept, y equals to 0, so it's 2,500 t divided by t plus 2. Here, if we eliminate this, we pass the 2500 divided by 0, that is 0. So the x-intercept, it's at 0, 0. So to graph the y and x-intercept is at 0, 0. We check the behaviors. And that's it.
The end behavior of our function is as x approaches infinity, y will approach 2500, and as x approaches minus infinity, y will approach 2500. In the context of the problem, we can say that the bunnies will not continue to increase indefinitely. When the value starts to reach 2500, the increment of bunnies will not be the same, and it will stop and never reach 2500. So the community of bunnies will never reach this value.
So in order to know if a rational function is increasing or decreasing, we need to look at their end behavior. So if the end behavior goes from negative infinity to positive infinity, we could say the rational function is increasing. And it is decreasing when the end behavior goes from positive infinity to negative infinity. Now, in our function, p of t equal to 2500 times d over t plus 2, we have right here the graph, and we could say that the one over here is increasing because it goes from negative infinity to positive infinity, and the one over here is decreasing because it goes from infinity to negative infinity. Now, considering the function, the whole function, we could say that the answer is that as x approaches minus 2 from the right, y approaches negative infinity, and as x approaches minus 2 from the left, y approaches positive infinity. Now, considering the context of the problem, we need to use only this part of the graph because the bunnies are reproducing, so they always increase the number of their population. They could not decrease because, well, it's not possible.
The domain and the range are really easy. The domain is x belongs to all the real numbers except for minus 2, while the range is y belongs to all the real numbers except for 2500. So, in the question number 4, it says, how many population would be at the beginning of 2006? Our answer is this. As you can see, the population of rabbits is 2,497.5 rabbits in 2006. The question also asks, how many will be the population of rabbits in 2020? Well, in 2020, it will be almost the same, 2,497.527. Our predictions were right. The rabbit population will almost but never reach the 2,500 of our vertical asymptote. Our general conclusion of the problem is that, of course, the rabbit population will always increase but never pass the 2,500 that we estimated, due to health problems or something like that. And about the topic, we can conclude that there are several ways of doing the rational functions, and there are also several ways of making it easier, and it's also of use of everyday life.